Hello everybody, I will start my today's another live coding session. So today I solve this question, range some query to the immutable. So given a 2D matrix under multiple query of the following types. Number 1, calculate the sum of the elements of the matrix inside the rectangle defined by its upper left corner and lower right corner. Okay. Implement the non-matrix class. Yeah, so there's only one type of query. Okay. And implement the non-matrix class, which has the initializer and sum region method, which handles the query. Returns the sum of the element of matrix inside rectangle defined by the upper left corner and lower right corner. You must design an algorithm where sum region works on over one-time complexity. Okay, good. So let me clarify my understanding first. So in this question, as the interface, I will implement the non-matrix class. Okay, and it should have the constructor, which should take the matrix, which is the 2D integer list, and returns nothing. Okay. Yeah. Also, I will implement sum region method, which takes row 1, which is integer index, row column 1, which is third index, and row 2, which is the index, and row 3, which is index, and I will return the sum. Yeah. Okay. Maybe this can be negative or positive. I think it doesn't matter that much. Maybe. Good. Okay. So this should be the, yeah. So I just want to confirm. If row 1 is always smaller than row 2, and column 1 is always column 2 or not. It should be, because row 1 column 1 should be left, upper left, and row 2 column 2 should be lower right. And also I should be able to say row 1 row 2 should be inside of the valid range. So I want to confirm this. And I check the constraint here. So, and yes, this is true and true. Okay, good. So let me take a look at some examples. Let's say I have a matrix, something like this. And let's say some region is called with 0, 1, and 1, 2. In this case, 0, 1 should be pointing to row 0, column 1, which should be this one. And row 1, column 2 should be this one. So I have to return the sum of 2 plus 3 plus 3 plus 4, which is 12. The 12 should be returned. Okay, good. If this is a single, cell, I should return the number, obviously. Good. So the brute force approach is just take a look at each cell and get the sum and return it. This could take up to O of nm. Let's say there are n rows and m columns. In that case, there are nm cells. And in the worst case, I have to take a look at each cell if if the rectangle is exactly the whole, given matrix. So I will optimize this. So here I can use the kind of pre-calculation. So in the pre-calculation, I calculate the sum from 0, 0, row column 0, 0 until that cell. So I take, 0, 0, 0 and specific cell and think of the rectangle, which is surrounded by these two, or should I say defined by these two cells and guess the total. I pre-calculated. Then I use that. I cache it. So let's call it pre-calculated sum left upper left sum. So when I think of this, it should be 1, 3, 6. And here this should be 3. I take a look at 1, 2, then this should be 1, 2, 2, 3, which is 8. And this should be, it goes like that. 15. So, yeah. So when I get this, what should I do? So something here, but I don't calculate it for now. So when I'm given this and this, I can say the sum until y is equal to sum from x to y is equal to sum from a bit annoying. Sorry. So sum from 0, 0 row column let's say this. This should be equal to, so this should be like this. And if I'm given the x, I can say I can calculate it in this way. The whole one minus this one minus this vertical something 1, 3. Then I add this one. As a compensation, because this one is, I mean, subtracted twice. So I can say this should be sum of x2. This should be sum until row of x minus 1 and column of y plus sum from 0, 0 until column x minus 1 and row should be row x. Like this. Wait, no. Row y. Then I have to append sum from 0, 0 to rx minus 1, column x minus 1. This is something I can say. So that being said, this calculation on the cache table pre-computation for upper left sums table, it basically takes all of nm because I just have to add the sum. I mean, from the, for each cell, I have to calculate the sum from the leftmost cell until each specific cell. And then I just have to add the number above, upper left sums of the cell above. In that way, I can calculate the upper left sum in the constant time for each in total of nm. And for each query, it takes a constant. Because, yeah, I can just have to calculate the sum from this formula. Okay. For space complexity, I need the, upper left sums table. So it should be of nm. Okay. So now let me start the implementation. Actually, I don't need the matrix here. Oh, by the way, the edge case I have to think is if given x is as the uppermost row or leftmost column, I cannot take rx minus 1 or like cx minus 1. So that's something I have to take care as the edge case. Okay, so self dot upper left sums. Okay, so in this way, I could initiate the empty, grid. So my task here is to do the pre-calculation. So for each cell, as I said, row sum. So I can calculate this. Okay, so now I've calculated something in the case of line 34. If I'm looking for this, I've calculated this sum. So I have to add the sum above. So this, I should say sum above. This should be like this. So row minus 1 and under the same column. But if this row can be 0, so if this row is 0, I don't have to add anything, so I do this. So now I got the total sum. I fill in self.upper left sums. Okay. Good. So now I'm done with the constructor. So I implement the sum range query. So as I said here, the return number should be self dot upper left sums row 2 column 2 minus self dot so basically I have to decrement negative do -1 for row 1 or column 1. Then plus this one. Okay, so let me explain what I'm doing. So when I'm thinking of from this to this, so I add this 0, 0 until y, and also 0, 0 until here. So this should be this range. So this should be 0, 0 to, row 1 minus 1 and column 2. Yes. And for vertical one, this should be 0, 0 until row row 2, column 1 minus 1. Yes. And for this one, it should be row 1 minus 1, column minus 1. Yes. Okay. But again, as I said, if row 1 is equal to 0, this is true for this case. If row 1 is equal to 0, I don't have anything to decrement. I do 0. With me. Yep. And do the same for line 64. And same for this one. Yeah. Okay. What happening here? If this. Okay, yeah. Good. So I return this. Okay. So now I'm done. So let me run my code. So I'm really wondering of the edge case of 0, 0 or something like that. So let's say I will do a very simple case like this. And I'm looking for the range from 0, 0 to 0, 1. Yep. In this case, I expect 3 to be returned. So let me get started. So here n rows is 1 and columns is 2. So I create the empty matrix, which looks like this for now. 2 columns, 1 row. So like this. And for each row and each, I start row sum solver with 0. And for column 0, row sum solver is self.upper left sums row column. No, this isn't correct. I have to add matrix row column. So now I get this one. This position is because 1. Now I get this becomes 0 to 1. Now sum above is because row is 0. This is 0. Okay. So I get 0, 1 plus 0 is 1. So this is now 1. Okay. Next, I come back to line 59 and column is now 1. So this part becomes 1 plus 2 is 3. And here in line 61, sum above, this should be, because now row is 0, sum above is 0. So 3 plus 0 is 3. I guess this one. Yep, so for this is good. So now I call the method with 0001. And here, because this is 1, 1, no, sorry, I call it with 0001. So it should be 0, 1, which should be 3. For this one, because row 1 is equal to 0, it becomes 0. For this one, the same, column 1 is equal to 0, so this should be 0. And here row 1 is 0 and column 1 is 0, so this should become 0. So I return 3 in the end. Okay, so this is as expected. So I passed this test case. Yeah, obviously I'd like to test some cases like only row 1 is equal to 0, or only column 1 is equal to 0, or row 1 and column 1, both of them are 0. So those test cases are must to be checked. But anyway, I'm pretty confident in my code, so let me submit. Ah, I see. So there should be access to the 2D grid. What's the problem with this? Syntax error, unexpected character after line concatenation. I see. So I can't have any character here. And maybe here, unmatched. So obviously this one. Type list object is not callable. Oh, so I'm doing it again. So this should be access to the 2D list. And for this. And for this. Okay. Good. Okay, accepted. Great. So let me quickly wrap up. So today I solved the question, range sum query 2D, immutable. So I'm given the 2D matrix and I'm given 2 cells and I return the sum of the cells defined in the rectangle defined by the given 2 cells in each sum region query. So in this question, I did the pre-calculation and creates a kind of cache matrix. This cache matrix has the each cell in this cache grid represents the sum of the upper left side of each cell. So I once pre-calculated, I can get the given rectangle's total sum in the constant time by using this formula. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.